everyone. We're going to evaluate the indefinite integral as an infinite series. We have the integral of x times cosine of x cubed dx. So we're going to use the Maclaurin series table and use this cosine of x here. I know it's hard to see. So let's look and see what. We're just going to look at cosine first. So if we just have cosine of x, that equals, and I'm just going to copy this down right here. So that's going to be the sum n equals 0 to infinity of -1 to the power of n times x to the power of 2n divided by 2n factorial. All right, now let's look at cosine of x cubed. Now all you do there is copy everything down. And instead of x, we're going to put x cubed. Divided by 2n factorial. Now simplifying this, this is going to give you the sum from n equals 0 to infinity of -1. I always forget my n, to the nth power. And this is going to be x to the power of 6n divided by 2n factorial. And finally, we're going to add this x. So we have x times cosine of x cubed. So basically that's just going to be adding, multiplying this by x. So if you have x to the 6th n power times x to the first power, that's going to be x to the power of 6n plus 1. So finally we have the sum n equals 0 to infinity and then -1 to the power of n. And then we're going to have x to the power of 6n plus 1 divided by 2n factorial. Now, the integration part is not that bad. It's pretty easy. So we're just going to integrate our x cosine of x cubed dx equals the integral of the sum n equals 0 to infinity -1 to the power of x, or times x to the power of 6n plus 1 divided by 2n factorial dx. Now, what we're going to go ahead and do is, once you integrate this, you're going to get, since it's indefinite integral, you're going to get a constant. So let's pull that out first. Plus, and then we write the sum n equals 0 to infinity -1. Always forget the n, to the nth power. And then for integrating this x, that's going to be x to the power of 6n, and you're adding 1, so plus 2, divided by your 2n factorial, plus you have to divide by this. So that's going to be 6n plus 2. And that's it. So finally, we've got this integrated, and your interval, your radius of convergence, it says it's all reals, so it is for this one as well. Our radius of convergence equals infinity. Thank you. Have a nice day. Bye-bye.